Okay, so we're going to begin the class by looking at lesson 503, which is finding the inverse of an exponential function. By the end of the class, you should be able to evaluate the inverse of an exponential function, evidenced by completing a Coach and Mathlete whiteboard drill. If there is time, we will get to that. If there isn't, then I will assign this as a team task. For now, I am going to assign the following to you guys. There is a warm-up, a 5-question warm-up. What I would like for you guys to do with parts 1A through 1D is to find the missing value. What you are looking for in these parts is to look for an exponent that makes these equations true. Once you finish that, you're going to go ahead and complete number 2, where you will find the inverse of this function. Remember that you're going to make a table f of x and list out the steps. And then you will make a table for f inverse of x afterwards. All right? So I'm going to give you guys the next 10 minutes. I would encourage you to work together. I'll be coming around if you guys have any questions. Otherwise, go ahead and get started at this time. So, like I told you guys earlier, we're looking for the exponents here. Just as a reminder, what exactly an exponent is. You're looking for repeated multiplication. That's exactly what an exponent is representing. So in this case, you're looking for how many times you should multiply 3 by itself to get 81. And in this case, 3 to the power of what gives you 81? Mir from Santiago. 3 to the what power gives you 81? How many times are you supposed to multiply 3 by itself to get 81? Let me give you some time to check in with your table mates, all right? I'll come back to you for the next one. Let me hear from Seth for this first one. A. 3 to the power of what gives you 81? 3 to the 4th power. Very good. Okay. Santiago, back to you for the next one. 5 to the what power gives you 125? 3. Good. Okay. C. 4 to the power of a number gives you 1 over 16. Just to let you guys know, whenever you start with a base that is a whole number and your answer is a fraction, then that means that your exponent is a negative. Because only a negative exponent will get you from a high number to a low number like that. Which in this case, if you were just trying to focus on the denominator, 4 times itself, how many times? Gets you 16. Twice. So you know that your answer is 2. But to make this a 1 over 16, then you just make this a negative answer. So 4 to the negative 2nd power is what gets you 1 over 16. And then lastly, we have a property here for D. Any number to this power is always going to equal 1. What is the power? 0. So this is to the 0 power. Okay. All right. Next, we look at the inverse of the function below, starting with the first step. So I just circle the first step. What would that be? Brian, how would I write that? Box minus 2. Next step in blue is what, DeMarco? Box over 5. The next step in green is what? James Reyes. What's the next step in green? 4 parentheses the box. And then our final step in purple is what? Rebecca, what is the final step in purple? Box plus 3. So now we go backwards and we start with the purple, right? What is the opposite of box plus 3? Mir from James Carpenter. Opposite of box plus 3. Box minus 3. Good. Okay, opposite of 4 times the box. Mercado. Box divided by 4. Opposite of box divided by 5, Lily. 5 parentheses box, so the number comes first. But good. And then finally we have box plus 2. So we can go ahead and rewrite this now. We're going to call this f inverse of x. In the first step, you replace the box with an x. That would be x minus 3. Divided by 4 is the second step. Multiplied by 5 is the third step. Plus 2 is your final step. So this right here, this equation that we get is our final solution. Okay. All right. Are there any questions before we move on? Okay, great. So the next activity is a 3 out of 4, and this is a team task. Anytime you see the label team task, this is something you're going to work on together as a group. So this is an activity for 4 people. You're going to have the following 4 math problems. You should be able to figure out the answer to 3 out of 4 of them. 3 out of 4 of them. 3 of these I have shown you how to do. The 4th one we don't exactly know how to do, and that's what we're going to focus on today. So let me give you the next 8 minutes, and you're going to answer with your team parts A, B, C, and D, or at least 3 out of 4 of them. If you have any questions, please call me over. Otherwise, this time is yours. You may. Okay, so let's come back together and see what you guys came up with. So in part A, we are trying to find the inverse of x to the 3rd power. So basically, we're looking for what is the opposite of raising something to the 3rd power, and that would be to take the cube root. So g inverse of x is equal to the cube root of x. Okay, that's what most of you guys came up with as I walked around. So that's good. In part B, it is asking us to evaluate g inverse of 125. So this is an input of the inverse, just so you guys know. So if g inverse of x is equal to the cube root of x, then if I attempt to find g inverse of 125, that means I'm trying to find the cube root of 125. And what is the cube root of 125? It's 5. All right, so far out of the 4 problems that we have, 2 of them we've been able to do. So it's pretty straightforward. Okay, now if we focus on the difference between g of x and h of x, what is the main difference between x to the 3rd and 3 to the x? Like, we have a 3 and we have an x, but are they in the same placement? No, it's like they're switched, right? Instead of 3 being the exponent, now x is the exponent. Instead of x being the base, now 3 is the base. So if we use our method of solving for the inverse, like we did in part A, then what should the inverse of h of x be equal to then? What should h inverse of x be? It would be a root. Where would the 3 go? Where would the x go? Okay, so it would look something like this. I mean, does this look out of place? It seems like it's mathematically correct. It seems possible. We don't know. We're going to figure that out in the next section. So let's take a look. So assuming that h inverse of x is the xth root of 3, then can we evaluate h inverse of 81? Given that h inverse of 81 would ask us to find the 81st root of 3. Have I taught you guys how to find the 81st root of a number? It's not possible. You cannot find the 81st root of a number, at least not traditionally. I'm sure there's a way. Now, just because we don't know how to do something doesn't mean it can't be done. And I'm going to show you what I mean by that. So, no, we cannot evaluate the 81st root of 3, but we can use our knowledge of inverses and originals, right? So, we know that we have the original, which we can then take its inverse. Now, if I have the input of an inverse, what is an input of an inverse in relation to the original? Is it also an input of the original? What does it become? Think about the fact that inverses are the opposite. So I'll ask the question again. I have an input of an inverse. What is an input of an inverse in relation to an original? It is an output. So an input of an inverse is an output of the original. Therefore, if 81 is an output of the original, can't I set 81 equal to 3 to the x, right? Where 81 represents the output and 3 to the x represents the original. Is that something that can be solved? 3 to the x equals 81. Yes, look at part 1a of your warm-up. What did you get when you tried to find 3 to the x equal to 81? You got 4. You got that x is equal to 4. So when we change things to something like this, 3 to the x equals to 81, that's something that we can find. But if we look at it in terms of 81st root of 3, yeah, it's not possible. Now, the reason why it's not possible is because the 81st root of 3 is not the correct inverse of an exponential function. We are going to explore the actual inverse of an exponential function just below. Okay? All right. Are there any questions on this task right here before we move on to the next section? Okay, then let me tell you guys what we're doing next. Partner challenge. So before I even tell you what this partner challenge is about, I'm going to give you 5 seconds to determine who will be your partner for this activity. You have 5 seconds. Ready? 5, 4, 3, 2, 1. You guys have your partners? Give me a thumbs up if you have your partners. All right. So this partner challenge is an an ancient puzzle. You are going to work with a mathematical puzzle that will provide clues to the inverse of an exponential function. Early versions of this puzzle were used by the Babylonians as early as 2000 BCE and the Indian mathematician Virsina around 800 CE. In the next 4 minutes, you are only going to focus your attention to this question that I'm highlighting right now. What do you notice about the relationship between the little number, the number in parentheses, and the number to the right of the equal sign? So you're looking at the completed puzzles, and you are answering this question in a sentence. Do not move ahead to answering these questions down below, because you only have 4 minutes, and in those 4 minutes, I want you to write a sentence. So time starts now. 4 minutes are on the clock. You may begin. Okay, so we left off then looking at the fact that little number is the base, the number in parentheses was the answer, and then the number after the equal sign represents the exponent. So if we use that logic then, what would the answer be for log base 2 of 8? 2 to the what power gives you 8? 3. So this first one is 3. We then look at the next one. 2 to the power of what gives you 64? 6. 2 to the 6th power is what gives you 64. Log base blank of 100 is equal to 2. So we're saying some number squared is 100. What would the base be? The base would need to be 10. Log base 5 of something is 3. So what is 5 to the 3rd power? 125. Log base blank of 81 is equal to 4. So some number to the 4th power is equal to 81. What would that number be? 3. And finally, 100. Log base 100 of 10 is equal to what? This is going to be kind of a tricky question because it's not very conventional. It's not a whole number. It's a half. It is 1/2. Now, the reason why it's a half, let me show you this. You might have not seen this in a while. So we're saying 100 to the power of something is equal to 10. Well, 100 to the 1/2 means 100 is equal to some number times itself 2 times. Well, that would need to be 10 times 10. And we only want one of these numbers. So that is how we get, 10. You can use 0.5. We just typically do a fractional approach instead. But either way is fine. Okay, so write the following down, please. Guided notes. The word log is short for logarithm. Although the idea of logarithms has been around for thousands of years, the modern symbol log was developed more recently. This symbol was created by a Scottish mathematician in the 1600s. So let's look at the first blank. Suppose k of x is equal to 6 to the x. This means that k inverse of x would be the following. It would be log base 6. Log base 6 of x. when we say this out loud, we say the following. We say k inverse is equal to log base 6 of x.
One mess.
You guys have one in maths? Okay, why don't we just leave a couple here from students? Just leave a couple here. You write this down. Log base 6 of x. Leave a stack group, please. Just like 5 is good. Thank you. Okay. So I'm gonna have you guys practice saying that out loud. I want you guys to get comfortable with the terminology for logarithms. So try to repeat after me. Log base 6 of x. Give that a try. Log base 6 of x. You guys go ahead and repeat that. Log base 6 of x. Log base 6 of x. Give it a try, you guys. No? All right. That's fine. Anyway, when you compute log base 6 of 36, you are looking for the exponent to which you must raise the base of 6 to get a result of 36. In other words, we want 6 to what power gives you 36? 6 to what power gives you 36? This means that log base 6 of 36 is equal to 2, because 6 to the second power is what gets you 36. Okay. Okay. We're going to write the inverse function for each of the following. Let's start looking at f of x. If your exponent is a number, as it is the case here, if your inverse is a number, then you do not need to take the logarithm. X to the fifth, we can rewrite as the fifth root of x. This is possible. It is not possible when we try to take the xth root of something. That's when it's not possible. But when we try to take the fifth root of x, or some number root of x, that is possible. Now, if your exponent is unknown, then that is when we can use a logarithm. So 5 to the x we can rewrite as log base 5 of x. So this would be appropriate. J inverse of x is equal to log base 5 of x. So I want you guys to know that the inverse of a logarithm is whatever the base to an x power, and vice versa. So log base 5 of x we can rewrite as 5 to the x. That is what the inverse of h of x would be. Now, this allows us to go back and forth between two forms. You have log form, and if you know log form, that means you can switch to exponential form, and you can also go the other way around. Now, what does that mean? Well, all you need to do is you need to identify what number represents the base, what number represents your answer, and finally, what number represents the exponent. If you know those things, that means you can switch from log to exponential form. For example, in log base 2 of 16 equals 4, we know that the base is 2. If the base is 2 and the exponent is 4, we can rewrite this as 2 to the 4th equals 16, where we can clearly see that 2 is the base, 4 is the exponent, and 16 is the answer. Similarly, if we know exponential form, as long as we identify the base correctly, the exponent correctly, and finally the answer correctly, we can switch back to log form. For example, here we are looking at log base what? What is the base for the second example? Log base 3 of, remember that the answer goes in the middle, So log base 3 of 9, and all of that is equal to 2. Log base 3 of 9 is equal to 2. All right. So let's get some practice with switching from exponential to log form and backwards. Let me walk you through the first one. Log base 5 of 625 equals 4, where 5 is the base, 625 is the answer, and 4 is the exponent. Therefore, we can write this as 5 to the what? 5 to the 4th power equal to 625. Okay? 5 to the 4th power equals 625. Next example. Log base 3 of 243 equals 5. Log base 3 of 243 equals 5. In this example, what is the base? Let me use my cards for this one. In this example, what is the base, David? 3. So 3 is the base. What is the answer, Jackie? What is the answer? 243. And what is the exponent? Carla, what is the exponent? 5. So we're going to rewrite this as the following. 3 to the 5th is equal to 243. Okay. All right. Next one. 8 to the 2nd equals 64. Here we see that 8 is the base, 2 is the exponent, and 64 is the answer. How can I rewrite this in logarithmic form? Noah, how can I rewrite this as a logarithm? Log base 8 of 64 is equal to 2. Log base 8 of 64 is equal to 2. Next example. I'm not going to label this one. I'm going to have you guys label this one. Let me give you guys about 15 seconds for this one. And then I'm going to call on the next person. Okay, how about I write this example? Jonathan Hernandez, how would I write this example? Excellent. Log base 822 of 1 equals 0. All right, next one. Switching from log base or log form to exponential form. Let me ask you the following. Hassan, what is the base? In y equals log base 4 of x plus 5, what is the base? 4. All right, good. What is my exponent? Santiago, what is my exponent? Look at it at number 11. 4 is the base, so it's either y or it's either x plus 5. That is my exponent. Y. 4 to the y equals x plus 5. All right. Next example. 2 to the x plus 3 power equals y. What is the base? Leilani, what is the base for number 12? 2. So this is log base 2 of what? What is the answer? Adrian, what is the answer here? X plus 3 is the exponent. Looking for the answer. Y. Log base 2 of y is equal to x plus 3. Okay. Log base 2 of y is equal to x plus 3. Number 13. Y minus 2 equals 5 to the x plus 1. Let's see. We haven't heard from a few of you guys. So, what is the base for number 13? What is the base for number 13? AJ, what is the base for number 13? 5. So it's log base 5 of what is the answer for number 13? Leo, what is the answer for number 13? Log base 5 of what? Y minus 2 equals x minus 1. Okay. Next one. Log base b of 3x plus 1 equals y minus 5. What is the base for this example? Let's see, James. Yes. Yeah, it is b. Good. B. B to the power of what? B to the power of, is it 3x plus 1 or is it y minus 5? To what power? Y minus 5. B to the y minus 5 power equals 3x plus 1. Okay. All right. So overall, it's not too complicated, switching back and forth between the two forms. We're going to go ahead and look at examples 3, 4, and then let's see, where would be a good time to take our break? I think we'll finish this page and then we'll take our break. All right, evaluate log base 2 of 16. So we're not rewriting this. I mean, we are, but we're going to evaluate it. So we're going to rewrite it in the aim of being able to actually solve it. So in log base 2 of 16, we know that 2 is the base. We know that 16 is the answer. So we're saying 2 to the power of something is equal to 16. What is that something? 2 to the power of what gives you 16? 4. The missing box is 4. In this case, log base 2 of 16 is equal to 4. Okay? Because 2 to the 4th is 16. In the next example, 5 is the base, and 1 over 125 is the answer. So we're saying 5 to the power of something is equal to 1 over 125. What must that something be? What must my exponent be? I'm going from 5 to 1 over 125. So the answer must be negative 3. Good. Answer must be negative 3. All right, you guys go ahead and try the next two on your own. I'll give you 2 minutes, and then we'll take our break. Okay, so we left off by evaluating logs. I'm going to show you what is known as the common logarithm. So anytime that you see a logarithm with a base 10, you might not actually see the base. For example, look at number 5. Log of 100. Log of 100 is assumed to be a common logarithm, which means that it is base 10. So log of 100 is actually the following. It's the same thing as 10 to the power of what equals 100. Well, 10 to the power of what gives you 100? 10 to the power of 2. So in this case, the box is equal to 2. Oh well, it's okay. So anyway, so in this case, log of 100 is the same thing as 10 to the second power, which is equal to 100. Example number 6. Log of 0.1 is the same as 10 to the power of what is equal to 0.1. Well, we don't typically look at decimals a whole lot, so we'd have to convert this to a fraction. 0.1 is actually the equivalent of 1 over 10. So how do I go from 10 to 1 over 10? It's real simple. The exponent would need to be equal to negative 1 to make this happen. Okay? All right, so let me leave those two up there. I'll have you guys try out number 3 and number 4. And I'll put up the answers in just a second. But go ahead and try these out. Take about 1 to 2 minutes for this. Mm-hmm. All right. But you try it. Number 3, 10 to the power of what gives you 10,000? Just count the number of zeros. 10 to the 4th power gives you 10,000. In example number 4, what is the value of log of 0.001? 0.001 is the equivalent of 1 over 1,000. So the box would need to equal -3 to make that happen. Okay. All right. Moving on to 7 and 8. This is the last thing I'm going to show you for today. The rest will be time for you guys to work on the coach and mathlete. However you choose to do that, whether it's with a partner, as a group. I won't be assigning it as a coach and mathlete because that's what we just did last class. So I'm just going to let you guys determine that on your own. Anyway, so number 7, find the inverse of the following function. Number 7, step 1, x minus 5, or x over 5. So we're going to make our table, m of x, step 1, is box over 5. Step 2 is minus 2. And step 3 is the logarithm. So as we work on making our inverse table, you need to know the following. The inverse of log base 3 of x, or log base 3 of the box, is going to be 3 to the power of the box. The opposite of box minus 2 is box plus 2. And the opposite of box over 5 is 5 times the box. So we get the following. 3 to the x plus 2. And all of this being multiplied by 5. Okay, so let me leave that up there for you guys to write down. And we'll move on to example number 8. N of x. So step 1 is x minus 4. Step 2 is 3 to the box. Step 3 is 2 times the box. Step 4 is box plus 8. As we look at the inverse, the opposite of plus 8 is minus 8. The opposite of times 2 is dividing by 2. The opposite of 3 to the box is log base 3 of the box. And finally, the opposite of minus 4 is plus 4. We get the following: x minus 8 divided by 2 log base 3 of all of this plus 4. Okay. All right, I'm going to zoom out, have you guys take a look at both of these in case you need them. If you can't see it, please take a picture, and then that way you can zoom in on your phone. Otherwise, this is the last bit of notes. The rest of this is for you guys to complete. You will not be completing all 26 questions. You will only be completing the following. You are to complete numbers 1 through 6, and then you will move on and complete numbers 23 through 26. And that is it for today. All right, any questions? Yes. Do not exit out. I will be assigning those at a later time. Okay.